Let's look at some examples of taking the derivatives of equations involving the natural log of x. From our notes and videos, we've learned that the derivative of the natural log of x is equal to 1 over x. So in the first example, we want to take the derivative of a negative 8 times natural log of x. So y prime then is going to look like, carrying that constant along with us, we have a negative 8 times the derivative of natural log of x, which is 1 over x. So here, y prime then, we can write as negative 8 over x. And there's our derivative. For part B, we have y equal to x to the fourth times natural log of x minus 1/2 x squared. So we have two terms here. We have the x to the fourth natural log of x minus the 1/2 x squared. In that first term, we have a product. Our product is x to the fourth times natural log of x. So we're going to be using the product rule. So here we have y prime equal to, using the product rule, we take the first, x to the fourth, which is the first factor, times the derivative of the second. The derivative of natural log of x is 1 over x, plus the second factor, which is natural log of x, times the derivative of the first. The derivative of x to the fourth is 4x cubed. Alright, so there's the derivative of that first term using the product rule, minus now the derivative of the second term. So we're going to use the power rule, bringing the exponent 2 out in front. 1/2 times 2 is 1. So we have x to the first power when we subtract 1 from the exponent. Alright, so then our derivative then looks like we have x to the fourth divided by x. So that's going to be x cubed plus, and then we have 4x cubed times the natural log of x minus x. So there's our derivative of y. For part C, we have y equal to natural log of x divided by x to the seventh. So here we have a quotient, so we'll be using the quotient rule. We have a numerator and a denominator. So here when we go to find y prime using the quotient rule, we have the denominator, which is x to the seventh, times the derivative of the numerator. Well, the derivative of natural log of x is 1 over x, minus the numerator, which is natural log of x, times the derivative of the denominator. The derivative of the denominator is 7x to the sixth. And then that's all divided by the denominator squared. X to the seventh squared would be x to the 14th. So now let's work on simplifying this. X to the seventh divided by x is going to be x to the sixth. Then we have a minus 7x to the sixth times natural log of x. And then that's all divided by x to the 14th. Here we can factor an x to the sixth out of both terms in the numerator. So we have x to the sixth. When we factor that out, we have 1 minus 7 natural log of x divided by x to the 14th. So now the x to the sixth cancels out with some of the x's in the denominator to leave us with x to the 8th. So now our answer looks like 1 minus 7 natural log of x divided by x to the 8th. Alright, for the next one in part D, we have y equal to natural log of 6x, and we want to take the derivative of this. Now notice we're working with not just natural log of x, but we have natural log of 6x. So we have more than just x inside the natural log. And from our notes and videos, what we saw was that the derivative of the natural log of a function is equal to 1 over that function times the derivative of that function. So here in this example, we can think of our function f of x as 6x. So here the natural log of 6x, we write it as 1 over 6x times the derivative of 6x. So we're still using that whole idea of 1 over x concept, but now instead of 1 over x, it's 1 over f of x, whatever that function is. And then we just have to remember to then multiply by the derivative of whatever that function is. So here, y prime is going to look like 1 over 6x, and then we have to multiply by the derivative of 6x, which is 6. Well, here the 6 in the numerator cancels out with the 6 in the denominator, so we are left with 1 over x. So there's our derivative of natural log of 6x. In the next example, we have y equal x squared times the natural log of 7x. So here we have a product. Our product is, we have an x squared as our first factor and then natural log of 7x as our second factor. So we're going to be using the product rule to take the derivative. So here y prime is going to look like, we have the first factor, x squared, times the derivative of the second factor. So the derivative of natural log of 7x. So we write this as 1 over 7x, and then multiply by 7x. Or sorry, multiply by the derivative of 7x. Derivative of 7x is 7. Plus, using the product rule, we have natural log of 7x now times the derivative of the first factor. So times the derivative of x squared is 2x. So now let's work on simplifying this. Notice here the 7's are going to cancel out. We have x squared over x, which is just x. And then plus 2x times the natural log of 7x. And there is our derivative. Alright, so for part F, we have y equal to the natural log of 7x squared plus 5x plus 3. So here we can think of everything inside the parentheses there, this 7x squared plus 5x plus 3, that is our f of x if we think about our formula here for taking the derivative of the natural log of f of x. Alright, so our y prime then is going to be 1 over our function, everything inside the parentheses there, which is 7x squared plus 5x plus 3. Now we're going to multiply by the derivative of everything inside those parentheses there. So then we're going to multiply by a 14x plus 5. So our y prime then is 14x plus 5 divided by 7x squared plus 5x plus 3. Our next example in part G, we have y equal to e to the 2x times natural log of x. So once again we have a product. We have e to the 2x as one factor and then natural log of x as a second factor. So we use the product rule when taking the derivative. So y prime is going to look like the first factor, e to the 2x, times the derivative of the second. The derivative of natural log of x is 1 over x. And then we have plus the second factor, which is natural log of x, times the derivative of the first factor. So we need to take the derivative of e to the 2x. Well, that's going to be e to the 2x times the derivative of our exponent 2x, so times 2. Alright, so let's kind of simplify this if we can. We have e to the 2x over x plus 2 times the natural log of x times e to the 2x. Alright, so there's our derivative for part G. Alright, for part H, we have y equal to the natural log of e to the x plus 2. So here y prime, we're going to take the derivative of the natural log of a function is 1 over that function. So 1 over everything in parentheses there, e to the x plus 2, and then multiplied by the derivative of that function, the derivative of everything in the parentheses. Well, the derivative of e to the x is e to the x, and then the derivative of 2 is just 0. So here y prime then is going to be e to the x divided by e to the x plus 2. So there's our derivative for part h.